All right, let's talk about solving equations. I know, it can feel super abstract, right? But what we're gonna do today is make it completely visual. You're gonna actually see the math happen, and it's pretty cool.
And I mean really see it. Not just crunching numbers to get some x equals whatever answer. Nope. We're talking about watching the solution literally appear right in front of your eyes on a graph. It's a super powerful technique, and that's exactly what we're going to break down right now.
So, how does this magic work? Well, it all boils down to one big and, honestly, surprisingly simple idea.
Okay, here's the secret sauce. The goal is to take one tricky-looking equation and turn it into two super simple lines. Think of it like this. Instead of fighting one big monster of an equation, we just split it in half. The left side becomes one thing, the right side becomes another. And those two things, they're just simple lines on a graph.
And the method is literally just 2 steps. It's awesome. Step 1, you write 2 new equations, one for each side of that original equal sign. You just say y equals the left side and y equals the right side. Easy. Step 2, you graph both of those new, simpler equations on the very same coordinate plane. That's it. That's the whole setup.
And here comes the magic moment, the solution. It's the x value of the exact point where those 2 lines cross paths. That one spot where they intersect, that's the treasure. The x-coordinate of that point is the answer to that big, tricky equation we started with. It's just that simple. It's incredible.
Okay, enough talk, right? Theory is great, but let's actually do one. We're gonna start with a pretty straightforward linear equation for our first challenge.
So here's the problem we're up against. Negative x plus 1 equals 2x minus 5. Now normally, you'd start moving stuff around, right? Adding x to both sides, all that jazz. But we're not going to do any of that. We're just going to graph it.
So just like we planned, we split it. We've got 2 teams. The left side, negative x plus 1, that's going to be our red team. Its equation is y equals negative x plus 1. And the right side, 2x minus 5, that's our blue team. Its equation is y equals 2x minus 5. See what we did there? We turned one algebraic problem into a visual showdown between 2 lines.
And now, we just look. Where do these 2 lines meet? You can see it right there on the graph. They cross at one single point. The coordinates are 2, negative 1.
But remember the rule? What's the only part we really care about for the solution? It's the x value. And what's the x value of that point? It's 2. Bam, that's it. That is our answer. X equals 2. We're done.
But, we gotta be sure. Is it really right? Let's do a quick check. If we plug 2 back into that original equation, on the left side you get negative 2 plus 1, which is negative 1. Okay. On the right side you get 2 times 2, which is 4, minus 5. Also negative 1. Negative 1 equals negative 1. It checks out perfectly. The graph didn't lie.
All right, that was awesome. Worked like a charm. But what happens when the equations get a little spicier? Let's level up our game and throw in an absolute value twist.
Here's our new problem. The absolute value of x plus 1 equals the absolute value of 2x minus 4. Okay, those vertical bars, they definitely change the game.
Here's the thing with absolute value equations. They're kind of like a 2-for-1 deal. Remember, the absolute value of something is just its distance from 0, so what's inside the bars could be positive or negative and give you the same result. This means that one equation is actually hiding 2 different possibilities we have to check out.
So this one problem actually explodes into 2 separate systems for us to graph. Case 1 is the easy one. We just pretend the bars aren't there. X plus 1 equals 2x minus 4. Case 2 is where we flip the sign on one side, so x plus 1 equals the negative of 2x minus 4. Now we have to solve both of these by graphing to find all the possible answers.
Okay, let's check out the graphs. On the left, you can see the graph for our first case. And look, it's got an intersection point. Now, look at the graph on the right for our second case. And what do you know? It has a totally different intersection point. This is the key, you guys. We're actually looking for 2 solutions this time.
So let's pull the x values from those intersection points. From that first graph, we get our first solution, x equals 5. And from the second graph, we get our other solution, x equals 1. Wow! So one absolute value equation gave us 2 answers.
And we're going to check them. If you plug 5 back into that original absolute value equation, you get the absolute value of 6 equals the absolute value of 6. Yep, 6 equals 6. Perfect. Now let's try 1. You get the absolute value of 2 equals the absolute value of negative 2, which is 2 equals 2. Also perfect. Both answers are totally correct. This graphing method is for real. Okay, so this is all cool for math class, but you might be thinking, when would I ever use this in real life? Well, let's take this visual thinking and apply it to a real-world decision you might actually have to make.
Let's imagine you're on a trip. You need to rent a car. You walk up to the counter and you're hit with a classic problem. 2 different companies, 2 different deals. Which one is better? This is a perfect situation to solve with a graph.
So here's the deal. Company A has a lower upfront fee, only $125, but they charge a bit more per mile, $3.25. Company B has a higher fee, $150, but they're a little cheaper per mile, at $3 per mile. So, which one do you pick? Well, the real answer is, it totally depends on how many miles you're planning to drive.
The real question we need to ask is, at what point do they cost the exact same? Where's the break-even point? Well, we can find out by setting the cost of Company A equal to the cost of Company B. And that gives us this equation right here. And hey, that looks exactly like the kind of problem we've been solving.
So we do exactly what we've been doing. We split it. We'll let the red line show us the total cost for Company A depending on the miles driven. And the blue line will show us the cost for Company B. And what are we looking for? You guessed it, that intersection point. That's our break-even point.
And there it is on the graph. The lines cross when the x value is 100. So what does that 100 mean in the real world? It means that at exactly 100 miles, it doesn't matter which company you choose. The price will be exactly the same.
And of course, the algebra backs it up. X is 100 is the spot. So now you know. If you're going to drive less than 100 miles, go with Company A. That lower flat fee saves you money. But if you're planning a road trip anything over 100 miles, Company B is going to be the cheaper option. The graph didn't just give us a number, it made the whole decision crystal clear.
All right, so let's bring it all home. What's the big takeaway here? What should you remember from all this?
It's this really simple but super powerful 4-step process. You split one equation into 2 y== equations. You graph both of them on the same plane. You find the x value where they cross. And that's it. That's your answer. You're basically turning something that's just abstract numbers and letters into a picture that literally points you to the solution. So, remember, this is way more than just a cool math trick. It's a whole new way of thinking visually about problems. I mean, you could use this for choosing a cell phone plan, figuring out a budget, anything where 2 things need to be compared. So I'll leave you with this question. What other big decisions in your life could get a whole lot clearer if you just try to draw a picture of them?